Hello and welcome. My name is Peter Christensen. This video is one of two sessions that I'll be recording on the topic of matrices. I'm currently enrolled in a Certificate 4 course in Training and Assessment, and I'll be submitting these videos as an assignment that I need to complete. So thank you for joining me. I'm glad you could be here, and I'm hoping that you're feeling relaxed and ready to go. And it would probably be a good thing to ask the question, what is a matrix? Well, in the bottom right corner I've put a few examples of matrices, and just to give you a flavour of what they look like. So let's get started. What is a matrix? It's a set of numbers in a grid with rows and columns. Now, it might only be one row and it might only be one column, but providing it's a set of numbers in a grid, then we'll call it a matrix. Now, there's nothing mysterious or special about it. Sometimes, or many times, it's written with a set of square brackets around it, but not necessarily. It's not the brackets that make it a matrix, it's the numbers themselves. So why do we use matrices? Well, they're a good way to organise numbers, and you'll see later in this video we're going to do a scenario where we'll be able to make use of matrices to make life a lot easier. Matrices also make it easier to solve problems, particularly complex problems. Matrices are paramount to being able to come up with a solution. For example, if you can imagine all the data that's involved in weather forecasting, we wouldn't be able to come up with a solution for finding out what the weather's going to be like tomorrow if we didn't use matrices and the methods that we've got for manipulating those matrices. So where are matrices used? Well, anywhere from engineering and physics, electronics, 3D computer graphics, data encryption. That's an interesting one, because if you've ever done internet banking, you'll probably be glad of the fact that your password or your PIN is safe and secure because it's been encrypted using methods that are associated with matrices. And also in places like geology or economics and robotics, you name it, there are so many places where matrices are used. I've just put in a handful there. So how do we use matrices? Well, first of all, let me ask you a question. How do you use a spreadsheet? Or how do you use a table? It seems like a funny question or a funny answer, but the answer is, well, you can use them however you want, really. Providing you define the numbers that go in it, then it makes sense to then start manipulating those matrices in ways that are suited to the situation. For example, the number 6 on its own is just a number. So how do you use that number? Well, you define what it means. If I was to define the number as the number of green pencils in my pencil case, then that now has a meaning. If I was to define it as the number of dollars I've got left in my bank account, it would probably have a more significant meaning and would require a different action plan. So the thing about matrices is that you define them and then you can manipulate them in ways to help us come up with solutions to problems. The interesting thing about them is that even though they contain numbers, as a group or as a set of numbers, a matrix can often be considered and treated as if it was a number itself. So you could have situations where you could have two matrices, two sets of numbers, and you can do things with them like add them together and multiply them and so on. And so it's very similar to some of the algebra that we use with normal numbers can be associated with matrices. And that's getting into the area of linear algebra, but that's not what we're going to do in these videos. But just be aware that there's a lot behind matrices rather than just explaining it to be a simple set of numbers in a grid with rows and columns. So What I'd like to do is, for this first video, not get too involved in all of the matrix theory that there is to learn. I'd like to start with a more intuitive introduction to matrices. And by that, I'm going to suggest that we look at a scenario where it's supposedly a real life scenario, which is something that I've just made up for the purpose of the video, but let's call it a real life scenario. But let's play along with the role play, and we will actually discover along the way that there are good reasons to have matrices, and we can actually discover some of the ways that matrices can be manipulated by adding them and multiplying them, so that in the next video, when I actually introduce matrix theory, you'll be able to look at that and say, oh, well, that's everything that we've covered in the first video. Of course it's like that. It seems to fall into place. So I thought it might be a fun way to actually get started. So what I'm going to do is talk about an idea I had, supposedly had anyway, for a business venture, and I'm going to now go and look at my screen, change my screen to have a look at my pen and paper, and I'd like to talk to you about my business venture called Peter's Cafe. Now let's suppose that I'm always trying new things, and I've got an idea for a cafe to make to provide tea and coffee and biscuits to my customers. And I thought, well, how hard could it be to run a business that does that? It's should be a pretty safe venture to get involved in, and could be a lot of fun dealing with customers along the way. So the other thing that I'd like to show you is that I've thought long and hard about this business, and I thought I should come up with a price list for charging customers for my provision of tea and coffee. Now, what I'm going to do is say, if you want a cup of tea, it's $2.40. If you want milk with that, it's another 30 cents. And for every spoon of sugar you want, it's another 20 cents. And if you'd like a biscuit, it's 60 cents. And obviously, coffee is a different price because it possibly takes a little bit more effort to make a nice coffee. But anyway, let's say that's my business venture. And you can help me decide if you think it's going well or not. But what I would like to perhaps suggest is that I don't think things are going as well as they should be, because I think even though I'd like to provide a prompt service for my customers, things don't go as well as they could do back behind the counter. And this is what happened. On our first day or first few days of service, we got in the back of the counter from the waiter, he'd written down a bill or an order for a table, and he's written it very nicely, and he's basically putting all the information that we need to provide table 15 with some cups of tea and coffee. And it says John wants a cup of tea with milk and 2 sugars and a biscuit. Okay, that sounds simple enough. And Paul wants a cup of coffee with extra milk and 1 sugar and a biscuit. And George wants a cup of black tea, no sugar, and 2 biscuits. And Ringo wants a cup of tea with milk, 1 sugar, and a biscuit. Okay, so that's all pretty neat and should be pretty self-explanatory. The problem is, if you just glance at that and quickly look away, you'll probably find it hard to even remember what it was that was written on the docket. So after a few days, I think I'd like to come up with a new way of doing things. I've got a new rule that I'd like to introduce. For all my waiters, whenever they're out on the floor taking orders, I'd like them to please write the order down in more of a table-like fashion that is easier to understand. So let's get out with the old and in with the new, and we'll take that same order, and I'll say that's an improvement, I think. You can probably see from that you've now got less information, even though all the relevant information is still there. So because it's laid out nicer, it's actually easier to see that I've got 4 customers, and I can quickly glance down and get a rough idea of what they might like. But after a day or two of that improvement, we realised that we're still not very quick out the back in terms of putting together the teas and the coffees. Because if you have a quick glance at that one and look away, it's a bit hard to even tell how many teas you need and how many coffees and so on, with how much milk, how much sugar and so on. So let's assume we come up with a new rule that says to our waiters, when you're out taking orders from tables, can you please put the order together in the form of a better looking table? So let's try that again. Out with the old and in with the new. And this time what you'll see is I've got the same information as before, but it's laid out so much neater. I've got all the teas and the coffees and the milks all lined up in columns, so that at a glance I can quickly tell that I need to make 3 cups of tea, 1 cup of coffee. I better get 4 servings of milk out of the fridge, 4 sachets of sugar, and 4 biscuits. And so that's a vast improvement than the original method of taking an order. So now let's follow along with this scenario. Let's suppose we make, for table 15, we get a tray and we put 3 cups of tea, a cup of coffee, with all those biscuits and sugars and so on together. We take it out to table 15 and Ringo says, hey, what about my order for a biscuit? I ordered a biscuit and it's not here. Well, that's a bit embarrassing. We don't like to have upset customers, but really our method that we've got of storing this information doesn't have any order for a biscuit for Ringo. It's just a blank. Well, Ringo tells us then that he was a bit concerned because the waiter didn't seem to be listening hard enough when he was speaking, and he thought that the waiter was distracted when he was taking his order, and he's forgotten or neglected to put the order of a biscuit down next to Ringo's name. So that's a bit of a problem. I thought we had a good system going with this new order, laying it out in the form of a grid. So I think we need to improve it even more. So let's come up with a new rule. And the rule says, if you're taking an order, please don't just write an order with blanks. Can you please fill out, if it's a blank, put a 0 in its place. So out with the old and in with the new. And now you can see that this is pretty obvious that the waiter has forgotten to put an order for Ringo's biscuit. Because he's left it blank, we know something's wrong. So rather than leaving it until we deliver the tray to the table and find out that Ringo is upset that we didn't bring his biscuit, we can tell straight away and go straight back to that table and say, oops, sorry Ringo, looks like I've forgotten to take your order for biscuits. Did you want any biscuits? And you say, yes please, I'd like 1 biscuit. So we can then get the waiter to add the 1 in there, and now that is complete. So that's like a matrix that's got rows and columns filled with numbers, and it makes its life so much easier to prepare those meals and get them out of the kitchen quickly and onto the right table. Okay, so that's talking about, we've actually done our first matrix of producing a matrix of, we'd call that the quantities of things that are being needed, to the ingredients that we need to put together. But at the end of the time when this group of people are ready to leave the cafe, they'll need to come to the cash register and pay. So what we're going to do now is we'll grab our price list and we need to do some calculations. So I'll put that over here. And okay, so how are we going to do this? Well, we better work out John's bill first. So we'll write John's bill, and we'll put in he needs to pay. Well, how are we going to do this? We'll read across. He had 1 cup of tea with 1 milk, 2 sugars and 1 biscuit. And so the price is coming down here, 1 cup of tea, 1 milk, 2 sugars and 1 biscuits. So we're going to have to multiply this number 1 times $2.40. So I'll just make a note of that. It's 1 times $2.40. And we're going to add that to 1 milk, which is, so add that to 1 milk times 30 cents. And then we're going to add 2 sugars, so we'll add 2 sugars, that's 20 cents. And we will add on 1 biscuit at 60 cents, so plus 1 biscuit at 60 cents. Okay, so that's basically John's calculations for his bill. Before I get out the calculator, let's just quickly work out Paul's bill. So Paul, he had no tea, but he had a cup of coffee. So we'll skip the first one and we'll go straight down to the second one. So it's 1 times $2.80. So it's 1 times $2.80 for the coffee. Plus he had 2 sachets of milk. So it's 2 servings of milk. That's unusual, but if he likes milky coffee, then we'll charge him 2 lots of 30 cents. Then he had 1 sugar, so it's 1 lot of 20 cents, 1 times 20 cents. And he also had 1 biscuit, so it's 1 times 60 cents. Okay, so if we add all that up, that'll be Paul's bill. Now the next one. So we're moving down in rows on this left-hand column, and for every item in this row, we're multiplying it by its corresponding item in this column here. So let's look at George. His bill. He had 1 cup of tea, so it's 1 times $2.40. And then he had none of the in-between ones, but he had 2 biscuits, so it's 2 times 60 cents. Okay, so we'll be able to work that one out pretty easy. And lastly, Ringo. He had 1 cup of tea, so that's 1 times $2.40, 1 times $2.40, plus he had 1 serving of milk, so it's 1 times 30 cents. Plus he had 1 serving of sugar, which is 20 cents. And he also had 1 biscuit, which is 60 cents. So it's 1 times 60 cents. Okay, so it's pretty easy to work out that if I add all this up, that would come to $3.70. If I add this one up for Paul, it comes for $4.20. If I add this one up for George, it comes to $3.60. And if I add this one up, it comes to $3.50. Okay, so what we've now done is, I'll just move this across to the right here, cover that over a bit. What you'll see here is we've now got a new column here, which is our bill. This section here is the quantity, and here is the prices. And if you multiply the quantity times the prices, you're going to get the bill. Now the bill is a set of numbers that we can charge for each of our customers who had these items here in this quantities list, and it was the special way that we multiplied those two things together that enabled us to come up with the bill. So just be aware that it makes sense to take every item in the first row times that column, and we'll come up with that first item here. Then it makes sense also to take every item in the second row followed by to multiply that by every item in that same column to come up with the second item, and then the third row for the third item, and the fourth row for the fourth item. So basically that's how we might treat working out the price list or the cash register part of getting these people to pay for their items. Now let's assume that we've been going for a while, and before they paid for their bill for their items, we found that there was an old docket from last week that they haven't paid. Last week they were at table 7, and it's the same 4 guys, and I remember now they said that they were in a hurry. They didn't, their credit card wasn't working properly, and they will come back and pay. So I reminded them that we need to not only pay today's bill, but we need to pay last week's bill as well. So now how can we deal with that? Well, it makes sense if we could say, okay, well, let's just add these two up. I'll get a fresh docket out, and I'll say, okay, here's this week's bill, and here's last week's bill that hasn't been paid yet. Why don't I just add them up, and we'll combine the two bills into one bill. So how do we add that bill with this bill? Well, we'll look at what John had last week. He had 1 tea, actually 1 tea this week and 1 tea last week. So I'm just going to say that's a total of 2 teas. So if he had 1 plus 1, I'll write the answer here as 2. And again, he had no coffees last week, or no coffees last week and no coffees this week, so 0 plus 0. And basically all you need to do is just add up the corresponding cells. So he had 2 sugars this week, only he had 1 sugar last week, so it was 3 in total. And for biscuits he had 1 this week, but he didn't have 1 last week, so it's only a total of 1. So if we just go ahead and I'll just add them up, 0 and 1 is 1, 1 and 0 is 1, 2 and 1 is 3, 1 and 1 is 2, 1 and 1 is 2. Okay, up to George. He had a 1 tea and 1 tea makes 2 teas. No coffee and no coffee makes no coffee. No milk makes no milk. No sugar makes no sugar. 2 biscuits and 1 biscuit makes 3 biscuits. Now for Ringo, he had a tea and a tea, that's 2 teas. No coffee, that's no coffee. 1 milk, that's 2. 1 sugar and 1 sugar is 2. And 1 biscuit and 1 biscuit, that's 2. Okay, so that was pretty painless, but now let's see what we've done. We've actually taken this order from this week and we've added on the order from last week, and we've arrived at a new order that we can now take through to the cash register. So it's a fairly straightforward procedure. I think you can see that we can take grids, providing the grids are the same size and everything's in the same order, then it makes sense to be able to add them together like that. And the way we added it was quite an obvious way. You take corresponding cells and you come up with the solution. Alright, so now we're in a position where we can take this to the cash register and say, okay guys, we're about to work out your bill, so please stand by while we bill you for it. Now I'm just about to do the price calculations again when I come up with a new idea. I've just thought of a better price list. Instead of having one column of prices for our regular customers, why don't we have an incentive program going where you could be a club member of our cafe, and if you join our club and obtain membership, we'll give you cheaper prices than the ones that our regular customers pay. So I'm going to take away this price list and replace it by another price list I've been working on, which is 2 columns. Now you'll see that I've got the regular prices the same as they were before, but if you're a club member, I'm going to give you 40 cents discount off your tea and coffee, and I'm going to give you 10 cents discount off your milk, and 10 cents off your sugar, and 10 cents off your biscuits. So let's now work out what this is going to look like if I'm going to create a bill based on these new price lists with this particular new set of quantities. So what I'm going to do is I'll take I'm going to say the bill is going to look like this. Now I'll put it in such a way that it's going to have two columns. You're going to have, just like before, you're going to have an answer for what's the bill for John, what's the bill for Paul, what's the bill for George, what's the bill for Ringo. That's our regular bill, but next to that we're going to have another answer here for what's John's bill if he happens to be a club member, and what's Paul's bill if he happens to be a club member, and for George and for Ringo. So the bill is going to be similar to the previous bill, where it's going to have another column of numbers next to it. So let's see if that makes sense. Well, I'm going to start with, as I did before, I'm going to start with John's row, and I'm going to multiply it by this column of prices here for the regular, and I'm going to put it here as to regular, and this is going to be club member, and this is the bill that we're going to work out here. So we can say, alright, I'm charging John for 2 teas at $2.40. That's 2 times $2.40, plus I'm charging 2 milks at 30 cents, plus 2 milks at 30 cents, plus I'm charging for 3 sugars at 20 cents, plus 3 sugars at 20 cents, plus I'm charging for 1 biscuit at 60 cents. So 1 times 60 cents. Now I'm not going to work this out, but I'm just trying to show you the methodology behind how we would work with these sorts of figures. So the next thing I would do is say, okay, well, before we move down to Paul's row, why don't we move across to this column here, and we'll work out the club membership bill for John if we use these prices instead. So we're going to go back and we're going to say John has 2 teas to pay for at only $2 each, so it's 2 times $2, plus he's got 2 milks to pay for at 20 cents each, so it's 2 times 20 cents, plus he's got 3 sugars to pay for at 10 cents each, and lastly he's got 1 biscuit to pay for at 50 cents. So 1 times 50 cents. Okay, so now moving down to Paul, we can see that he's got 1 tea to pay for at the regular price at $2.40, so it's 1 times $2.40, plus 1, he's got a coffee as well, so he must have had, let's see, what did he have? Okay, this week he had a tea, and last week he had a coffee instead. Sorry, this week he had a coffee, last week he had a tea, so that's why it's 1 of each. Okay, so he's paying for 1 times $2.80 for this regular bill, and then he's paying 3 milks at 30 cents each, so 3 times 30 cents, plus 2 sugars at 20 cents, that's 2 times 20, and finally 2 biscuits at 60 cents, 2 times 60. So whatever that number is, I can put that there. And of course, I'm not going to waste our time just going through and finishing this, because there's a fair bit of writing down and a few bits of calculations to do. But what I'm wanting to show you is that, let's suppose the answers to our questions might be that the answer is $6.60, $7.70, $6.60 and $7. And let's say the club membership price was $5.20, $6.20, $5.50 and $5.60. I've actually worked out these numbers beforehand, so what we can now say is that our new bill has got 2 columns of numbers. Now that is not so unusual, because when I get a bill for my gas and electricity, I get an invoice to say you should pay this much. However, if you are a concession holder, then you only need to pay this much. So it's the same bill, just got 2 prices on it. So here's a situation where I'm being able to take a quantities matrix, which is this one here, multiply that by a price list matrix, and the price can have more than one column, and we end up with a bill matrix which has got more than one column as well. And that's all quite sensible thing to do, and it just it makes sense that we would actually be treating our information in our tables like this, in terms of taking things and multiplying them. So what have we seen today? We've seen that you can take matrices, or make matrices, and we can see that you can put them together in a way that makes life a whole lot easier. We need to have a few rules, like you can't have blanks. We shouldn't have blanks, because a blank doesn't necessarily mean a 0. A blank might mean that you've just forgotten to put a number in there. So we've also seen that you can add matrices and you can multiply matrices in a certain way that makes sense. So what I'm going to do now is just leave this video, and we'll come back in the second session where I'll give you some more formal introduction to matrices and some of the notations, and show you how we add and multiply, and what you can do with matrices to solve some real life problems. So thanks for staying around and watching this, and I hope to see you again in the next video. Bye.